I spent all this time swapping this Cummins engine into this Ford Explorer, had to stretch the front end of the car and do a million other things to make it fit, and I hadn't gotten around to building a hood for it yet. Not having a hood might ruin this entire engine swap because it's so covered in snow, it's going to destroy this nice new Cummins engine I put in here. I really need a hood for this thing. It's time I finally built one.
Now that's impressive. That battery was sitting for a long time. Grid heaters work.
I swapped a full-size 6BT Cummins engine out of a full-size truck into this little Ford Explorer. And in order to make it work, I actually had to stretch the front bodywork and push the radiator forward in order to get the engine to fit. On these fenders, about there to there is a section of sheet metal that I welded in order to stretch the front end about this far. And then I also took the radiator, which used to sit here, and pushed it about that far forward as well. The reason I did that was first because the engine was really long, big inline six turbo diesel engine, very long engine. And second, because this turbo diesel needs an intercooler and a giant radiator, and I was able to make it all work with the stuff that came with the Cummins truck from the factory. So it all works, it's all packaged nicely, but the front end had to grow. As soon as it was drivable, I just started driving it. I never bothered to make a hood. I've been driving this thing around without a hood for quite a while now, and it's time I put a hood on it. I get a lot of rain and snow and weather here in Colorado, and it's piling up on this bare engine and things are starting to rust. The engine is the crown jewel of this entire swap, so I don't want not having a hood to compromise the whole purpose of the swap, which was the engine. Things are starting to rust. I need to protect this thing. It needs a hood. Full disclosure, I'm already done. The hood's already on this thing, I just don't want to show it to the camera yet. It ended up being a lot more work than I thought it was going to be to add a hood to this thing. Just like on the fenders, I needed to add about that much length of hood in order to make this thing work. And this whole adventure ended up with me having to swap the radiator out, make some upgrades to the engine, modify the transmission mount, learn how to stamp sheet metal with a garage press, and a whole bunch of other shenanigans that you'll see in this video. It ended up being a lot more work than I thought it was going to be. If you want to see all that, stick around and watch the video. Let's get to work. Okay, first things first. I need to make a plan. My first thought was, I just make the entire thing out of fiberglass. Now this would be fine, except I priced out the glass and every single layup was gonna be about $500 worth of fiberglass. That's fine, that's not a big deal, except when you're making a fiberglass hood, you don't just do one layup. Let's say this is a cross section of the hood. In order to make the hood, I need to do one layup, which is the hood itself. But in order to get a layup of the hood, I first have to make a mold, which is the inverse of the hood that you lay it in. So that's another layup, 2x the cost. And then I've never worked with fiberglass before, so this fiberglass part I was probably going to have to make 2 to 3 times before I actually get the part right, because I don't trust myself to do it the first time. At that point, if I have to make a mold, and then I have to make a hood, and then I might have to remake the mold or remake the hood, I might have 3 or 4 different layups that I have to do. Now it's no longer $500, now it's $1,500 to $2,000. That is a lot of money for a hood. Now I'm sure you're telling me you can do it a lot cheaper, but really doing a mold-based construction is the right way to do it, and I don't have any practice in fiberglass, so I'm not going to get it right the first time. This is what it's going to cost me. Whether or not you could do it cheaper or not, that's what it would cost me. That is a ridiculous amount of money for a hood. So instead of doing that, I figured I'll just do it like the fenders and make it out of sheet metal. Here's my cross section of the metal hood again. All I'm gonna do is I'm gonna cut it in the middle, or at least I'm gonna cut it in the spot where there's the least amount of curvature so that I don't have to do any sheet metal bending or anything. And then what I'm gonna do is I'm just gonna weld new sheet metal in the center in order to extend it to the length that I need. If I do it this way, it means that I don't have to figure out a way to make these curves like in the front of the hood where it goes over the lights. Doing it this way minimizes the amount of curves, minimizes the amount of bending because I don't have any bending equipment. There's only one issue with doing it this way. So this was a side view. Now let's look at a top view. This is what the top of the hood looks like. The hood actually has 3 channels in it. And when I slice the hood, this section of hood that I'm gonna have to make is gonna have to have these 3 channels in it. I need to find a way to stamp channels into sheet metal in order to make this part that I'm gonna be welding into the center. So that's the plan. See if I can make it work. I'm already running into one of my first problems on this thing. This Cummins Explorer has a hood stack, which is going to make it pretty difficult to test fit this hood. So one of the first things I want to do is address this hood stack. Since I'm having to pull it off right now anyways, I figure it might be time for a good upgrade. This thing is way too loud. I want to try and figure out a way to add a muffler to this, despite the fact that there's only a few inches worth of pipe in here. Now, I don't need this thing to be quiet, but I definitely don't want to have to wear earplugs every time I drive it. If you're welding piping or tubing, especially if it's stainless, you want to be able to protect the backside of the weld. Normally this is done by running purge gas inside the tube or pipe. But welding gas is really expensive, so I prefer to use this product that's called solar flux. You apply it to the back of the area that you're going to weld, and then the heat from welding takes this powder and turns it into this glassy, ceramic-y substance that keeps oxygen off the back of the weld. This stuff works awesome and it's way cheaper than purging the entire pipe with welding gas. However, it can leave some particulate behind, so you don't want to use it anywhere that might be sensitive to getting particulate inside, like a cooling system or something. It's great for exhaust though. Any particulate just gets blown out the back of the car. Or I guess in my case, the top of the hood. This is the difference between using solar flux or some other type of backing and not backing your weld. On the left, all those little crystal looking things are called sugaring. Whereas with the solar flux, you can see that there's just a glassy layer over the top, but there is no sugaring. Sugaring is an indication that there was oxygen on the back of the weld. The oxygen has allowed the chrome in your stainless to bind to things that you didn't want it to bind to. And when the chrome is bound to those things, it can't bind to the things you do want it to bind to. Your stainless is no longer stainless. Every bit of sugaring is removing corrosion resistance from the metal. You don't want to see this on your weld. Not if you care about corrosion. It's time to attempt to make these channels in the sheet metal panel. I don't have any fancy sheet metal tools. The closest thing I have is a cheap garage press from Harbor Freight. We're gonna see if I can make it work though. I bought some square stock that was the right dimension to use as a stamping tool, and then I bought some square tube that was the right dimension once I cut it up to use as a die. I don't expect this to be perfect because metal stamping is a very complicated process, but it doesn't need to be perfect, it just needs to be good enough. The first one I took off the press actually didn't look too bad. It wasn't perfect, but I'd say it was passable. I tried to stiffen up the tools a little bit, and I went for it with the sheet that I'm putting in. A consistent issue I ended up having was that with a single ram on the press, it was only pushing down at one spot, and I ended up bending this key stock. For a 10-inch wide piece, I think you really need a ram that pushes down on both sides, or you need a lot thicker piece to do the pressing. I pressed too hard on this. It meant that on either side of the bend, one side was always deeper than the other because I just wasn't getting consistent pressure. It was pushing harder on one side. And then it meant when I tried to push really hard to correct for that, on this stamping, I actually ended up billowing out the center here. So there's a few issues with this, but I'm hoping that I'm gonna be able to fix them with the body hammers. Getting this thing to fit upright was very difficult. I kept tacking it into place, realizing that there were parts that didn't meet up perfect, cutting the tacks, regrinding, and then redoing that over and over. Part of the reason why is because I was relying on the curvature of the hood in order to curve the new panel into the correct shape, but it just meant that fit up was very difficult. So I got a major problem. I tacked this hood all up, and before I did the finishing welds, I wanted to test fit it to make sure it fit. And it does not fit. At first I was worried that I had a huge problem and that it was all warped out of shape, or that the way I had done this was just wrong to begin with and it wasn't gonna fit. But that's not actually what happened. Believe it or not, the one spot that this hood isn't fitting is that it's running into the radiator cap right here. I would have never guessed that the radiator cap was gonna be the thing that prevented me putting this hood on. So I had some decisions to make. And what I decided is I'm going to get a new aluminum radiator. I'm gonna chop the filler neck off, and then I'm gonna weld some plates to block off where the filler neck was. You can't have clearance issues with your filler neck if you don't have a filler neck. Of course, I will still have a filler neck. I'm just gonna put it in line with one of the hoses rather than being on the radiator itself. This is actually gonna solve a ton of problems for me. First off, when I get this new radiator, I'm gonna get some electric fans to go with it. When I first put this stuff in the Explorer, I used a mechanical fan, and the reason why is because mechanical fans cool better. Don't at me. It takes a lot of power to turn a mechanical fan, and that's why people don't like them. Electric fans use less power, but that's the equivalent of saying that the mechanical fan is moving a whole lot more air. But at this point, it's causing more problems than it's fixing. For example, my coolant overflow bottle is in the way of my air filter, and I have to use this tiny little squatty air filter because I just don't have room for a bigger one. Moving to an electric fan setup will free up some space in the front, and I can mount an overflow bottle somewhere else, which means I have more room for the air filter. And some other stuff I'm gonna add later. On top of that, I would really like to angle my drivetrain down more to get a better drive shaft angle, but if I do that, the mechanical fan runs into the radiator. If I go with electric fans, then the angle of the engine doesn't change the angle of the fan anymore. I can angle the engine more to get a better driveline angle. I did not think I was gonna be tearing apart the entire front of this Explorer in order to install a hood, but that's where we're at, so that's what we're gonna do. I did need to replace the harmonic balancer anyways, so tearing apart the front end will make that a little easier. Overall, this will end up being a whole bunch of upgrades for the Explorer. It's worth doing. Man, taking the front end off this thing really reminds you that there's a Cummins underneath here. This is a lot of cooling package stack up for a Ford Explorer. From here, it definitely looks like a giant turbo diesel out of a truck and not a tiny little gas engine out of an SUV. Well, in case you're wondering, this is everything it takes to cool a Cummins. This is why I ended up having to stretch the front end. It wasn't really because the engine wouldn't fit, it's because all this cooling wouldn't. It takes a lot to cool a Cummins. While I'm in here, I'm going to replace the old harmonic balancer with a nice new fluid damper. Should help with some of the vibrations from this thing, and it helps you get a little more RPM. I do plan on tuning this thing up a little bit in the future, so this is a good supporting mod. When you do the math, RPM equals horsepower, so trying to get a little more RPM is always good for power. Here's something that's going to be controversial. When torque is critical, the appropriate way to apply thread lubricant and anti-seize is the lubricant or the thread lock goes on the threads, and then whatever you're using for a lubricant, not thread lock, but lubricant, so either anti-seize or oil, goes on the washer. What you want when you're setting a torque spec is you want all the torque to go into rotating the bolt. Any torque that's from friction from the threads or from this washer throws off your torque reading. So you want the face of the bolt and the face of the washer to be lubricated so they don't affect your torque rating. And you also want the threads to be lubricated because lubricated threads give you about 20% more torque than when you don't lubricate them. Trust me, I'm an engineer. All right, here we've got old radiator and new radiator. There's two key differences. First of all, when you look at the end tanks, this is an all aluminum radiator with aluminum end tanks. This has plastic end tanks. Now the reason that matters is because I need to modify this one and I can weld aluminum, I cannot weld plastic. This one also has electric fans rather than the mechanical fans that came stock on a Cummins. This was a very cheap radiator. It was like 300 bucks or 400 bucks online. I don't actually expect it to be very good quality, but it came with electric fans and it's all aluminum and that's what I needed. The other advantage is that this whole electrical fan stack up takes up way less room than the stack up did with the mechanical fan. Especially on the sides of the engine, you can see this side has like a 5-inch duct over here, and then over here it's got this coolant bottle that takes up a bunch of space and got in the way of my air filter. By moving to the electrical fan, I should be able to get rid of this, and then I'll relocate it with an external coolant bottle somewhere, and that'll allow me to run a bigger air filter. And then on top of that, there's some other components I want to put on the front of the engine that this junk was blocking, and I'm going to be able to do that now. More on that in a future video. Now this isn't that surprising, but the cheap fan came damaged. This mounting tab's all crushed and bent from shipping. So I will have to bend that back into shape, but that's not a big deal. I haven't found a great way to cut aluminum. You're not supposed to use a normal cutoff wheel because the aluminum will gum up the abrasive and then the disc can shatter. So you're supposed to get aluminum specific discs. I have some of those for my tiny little die grinder, but these don't last very long. I went through 2 of these just trying to cut this off. They worked all right, they just didn't last very long. The Sawzall blade was all right, but I ended up bending that. The one thing that did work well was my flap disc. I just used a normal flap disc for steel, but I used a brand new one so that I didn't contaminate this with steel. I figured this would be fine because if it gums up the sandpaper just chips off and wears off like normal, so it's not going to blow up the flap disc, it's just going to wear it out quicker than using steel. They make aluminum specific flap discs, but this actually worked really well. In the end, it turned out fine, but I'd really love to find a better way to cut aluminum. Now all I gotta do is seal this off and weld it shut. I bought some aluminum on Amazon and I'm just gonna use 2 plates. 1 plate here and 1 plate here. This stuff is super thick, 1/4 inch, 50-52. 1/4 inch is a lot thicker than what this was made from, so it should give me some wiggle room. If the welds aren't perfect and everything, it should still be pretty strong. A radiator is technically a pressure vessel, but it only takes 30 PSI, so I think 1/4 inch plate, it's going to be hard to screw up. So let's cut up this plate and give this a shot. My aluminum welding skills are not where I'd like them to be. I haven't had a ton of practice with it, so here's hoping this goes all right. I really don't want to have to try and cut off this plate and redo it because it was such a pain to cut on the aluminum in the first place. So I really hope I get this right the first time, but we'll take it slow and careful and hopefully we can get it. Now that didn't turn out too bad. It didn't turn out perfect, but that should work. I really need to figure out a way to leak test this before I put it in the car because I don't want to be trying to weld on this thing while it's in the car. And other than that, I'm really just hoping that gave us the height we needed and that I'll be able to fit the hood now. Because if that didn't work, I'm not sure what I'm going to do. Straight enough. A little crooked never bothered me. This was a very leaky setup, so I could only test it to about 7 PSI. But as far as I could tell at that pressure, there weren't any leaks. So for now, we'll call that good. Before I run the car, I'll test it again with the entire cooling system hooked up.
To anyone who says that electrical fans will save you space over mechanical fans, take a look at that. This is practically touching. This is where the mechanical fan would go, and you see the electrical fan takes up so much space, it's not that far away. Electric fans don't save you very much space, at least not on this engine. Granted, I did go with a 4-core radiator because I figured bigger's better, and it's about half an inch thicker than the old radiator. But still, there was not a lot of room to be saved by going to electric fans, if any at all.
The final thing I need to do on this radiator install is wire the 2 electric fans. Luckily, the kit I bought came with the relay and all the wires I need to do that. It also came with a temperature switch for turning the fans on and off when I get to the right temperature. Now, the normal spot this goes is on the back of the cylinder head, but I'm already using that for my gauges inside the car. So instead, I found a free spot on the front of the block. Right here, right next to the fans, is a spot that normally it runs a coolant hose to be used for your automatic transmission cooler slash heater. I got rid of that giant liquid to liquid transmission cooler when I went to a manual transmission, so this spot on the block is free, and all I needed was an adapter bushing to be able to put the sensor in. I noticed something kind of neat. I've got an empty space in my fuse box that is meant to be for ABS. This thing is never going to have ABS, so I'm just going to reuse this spot. I'm able to put the relay in there, and then it's already fused for 30 amps, which is the fuse size that the fans wanted anyways. So I've already got my fuse and my grounds and basically all the wiring done except for running power to the fan and running the switch to the temperature switch. All I'm gonna have to do is cut into a couple of these wires and run 2 or 3 wires rather than 8 wires, and that'll be a lot easier. Let's go mechanical engines. It gives me more fuse box room. Alright, the radiator's in, the fans are wired. It's time to modify the transmission crossmember so that I can angle the engine a little bit more. This should help with my driveline angle. Here's the transmission crossmember that was under the Explorer. In order to drop the transmission down, all I'm going to do is cut off the old riser plate here and then cut these slots in the bottom of the mount. Cutting this off will give me an 1.5 inches or so of drop, which will equate to 2 or 3 degrees of drive shaft angle, and that's exactly what I'm looking for. If that turns out to be too much, I can always put spacers underneath it to bring it back up as high as I need again. Well, there we go. This whole piece removed like it never even happened. Welds ground down all nice. Got some holes that look reasonably squarish. This cheap little plasma cutter that I got from Amazon, it worked well, but it wouldn't puncture all the way through 1/4 inch plate. So I just had to drill a hole to start. And once the plasma cutter had a hole to start from, I was able to cut it out. These are here in case I get high centered. I want to make sure that the high point is actually this metal here and not the bolt or nut for the transfer case. I want to make sure I can't run into these nuts and break them off or bend them or do any damage to the drivetrain. I started it a couple times just to confirm that it wasn't running into anything. Now that the engine's at a slightly different angle, it seems to be fine. Time to try and get the hood to fit over this exhaust. So I'm glad I test fit this. It's not hitting the radiator cap here anymore, but there's still quite a bend in this side. And if I put it all the way down, I've got a big bend in the sheet metal. So I need to grind this weld out and see if I can't relax it a little so it can go convex instead of concave. The way I had been welding this, it was just adding a bend to it, and I need to fix that. And it would have been impossible to see that if I hadn't test fit it, so I'm glad I test fit it. So I'm learning something about doing the sheet metal on this hood. When I stuck it on the car, the edges were sticking up a little higher than they should have been. I knew the hood was curved in this direction, but I was hoping that by bending the sheet metal into place and welding it onto the existing sheet metal, that would take care of my curve in this direction. Unfortunately, this sheet metal isn't very strong and this is a little thicker, so that didn't completely give me my curve side to side that I wanted. So the first thing I'm doing is I'm coming in with my body hammers and trying to add a bit of curve here. But that's not the only problem. It's actually a compound curve. It doesn't just curve side to side, it curves front to back. That curve front to back is the other thing I need to deal with, so I'm also going in with the hammer and dolly and trying to give it that curvature front to back. This curvature is a lot more obvious when you look at a side view. This whole thing should slowly curve down until it gets to this part of the hood, but you can see there's spots in here where it's actually straight. So what I'm trying to do is add in that curve front to back the whole way across the hood in order to make it fit better. It's my first time using body hammers and I'm learning a lot, but so far I think I'm getting it roughly into the shape that it needs to be. All right, so that's all the welding and grinding done for the most part. What's left over is there are some spots where it's not laying perfectly flat. There's some areas that are slightly dented. So my next move is to grab the body hammers and go crazy trying to get this whole thing straight. My goal is I don't want there to be a sharp seam in this when I'm done with it where you can obviously tell where I've patched in the metal. If I can make it fit and get rid of that sharp seam, then I'll be happy. I've been banging on this hood with a hammer and a dolly for a lot of hours, and there's still some pretty big adjustments that need to be made. There's going to be a lot of hammering in order to reshape this metal into the right shape. I figured it's going to take me like 2 weeks to hammer this in manually. Rather than doing that, I found some attachments online for an air hammer. So I'm going to try an air hammer and a dolly. We'll see how that does. Now these are pretty cheap attachments. The surface finish on them isn't great, which means this surface finish is going to transfer to the sheet metal. But I figure if I put this hammer on the bottom and then I put the smooth dolly on the top, then I'll get my smooth finish on the surface where I need it. Let's give this a try. See if this is going to save me a bunch of time. Or if I just get frustrated and say screw it, the hood's good enough as is. I can't really tell if that's working yet, but one thing I should know is that this crap is loud. According to OSHA, if you have over 90 decibels or so of noise, whatever the actual number is, you're meant to wear double hearing protection. That means for me that I have these little plugs in my ears, and I have this over-the-ear protection over the top of them. Double hearing protection. I'm pretty young and I'm already going deaf, so I really like to protect my hearing. You should too. So I've succeeded in taking a lot of this side of it and making it a lot rounder and doing the same on the other side. But the issue is that this metal was just never the right shape. It was never perfectly the right shape to begin with. As I get this closer to being the correct shape of the hood, it's causing problems elsewhere because it's causing the metal to move from here over to other places that I don't want it to be. One issue it's causing is that it's starting to wrinkle up in this area, which means this interface from the ridge that I stamped to the existing ridge on the hood is now a lot more obvious and doesn't look nearly as good as it did. But the major issue it's caused is this edge actually split. The weld along here has been splitting. On top of that, all the grinding and shaping got the metal so thin in that spot that it's actually worn all the way through. You can see the light sticking through that. The more I try and make this perfect, the more I'm realizing it's never going to be perfect because it was never cut out perfect to begin with. I'm about at the point where I'm just going to say, screw it, this thing's good enough for what it's going on. It's going on an off-roader. I've never cared to have done it up, body panels. The one thing I wanted to avoid was having really bad wrinkles and on this interface here that make it really obvious that I added material to the hood, because that's how the fenders are. But I'm convinced that with sheet metal work, you can just sit there and bang on it for as long as you want. At a certain point, you just have to say it's good enough. I could spend 100 more hours beating this thing into shape just to bump a rock with it the first time I take it off-road and having it get bent up. So I'll see what I can do about fixing the split in the metal and the bad and the worst spots, but I'm about at the point where I'm just gonna say screw it and throw some body filler and some paint on it and call it good enough for an off-roader. It was never meant to be a show car. It can be really difficult to convey a sense of how much time these projects really take through a YouTube video. For context, the first clips from this video are dated from July, and I'm editing this coming on December. I don't know when this video is going to go out, but that's a long time to work on a single video. Of course, there were other videos that I'm working on in the meantime, but these projects take a long time. After I spent months trying to get a hood on this car, it can get a little frustrating. But I'm bound and determined to make this thing work, and frankly, it ends up turning out all right. So I was trying my damnedest to install this hood latch on that hood, and the problem is that with the Cummins radiator, the radiator just sits way too high in the car. In order to catch this latch, the hood is not in the right position. And it would have been a lot of work and modification to try and get a way to mount this where it would have actually worked properly. On top of that, with all the metal I've removed from this hood and everything, the hood's kind of floppy, and I don't like this just captured in the middle. It did not feel as stable as it could have felt to me. So I got frustrated with trying to mount this, and I did something I rarely do, which is I spent some money in order to avoid my problem. I usually don't recommend that, but sometimes it's the right answer. What I ended up doing was buying these hood latches. It's from a company called AeroCatch, and you simply install this pin on the radiator in my case, and then this pops open like that, and you have a nice little catch to secure your hood down. And this kit comes with two, one for each side. Having one on each side should hold the hood a lot more firmly than having a single hood latch in the middle. And on top of that, it comes with a locking key. The lock cylinder isn't great on these, it's kind of cheesy, but having a lock in general was pretty important for me. I've had batteries stolen out of cars before, and I don't want to have that happen again. So, time to get these installed. This will save me a lot of work. They look kind of snazzy, and they do everything I need them to. So I got these pins for the hood that I need to install. But the problem is, it only came with a nut for either side, and this radiator core support has metal on both sides. I can't reach up in there and get a nut on that very easily. So what I did instead is I bought a whole big bag of these weld nuts. Those go on there, I weld them on, and then I'm able to put that on there like that with a little lock nut. Much easier to install. It means I can install it blind and then just tighten this lock nut here in order to set the adjustment. Kind of wish these pins had come with this weld nut setup to begin with, because installing them blind with double nuts like that is not easy. Weld nuts are cheap, but I certainly didn't have some N10 by 1.5 laying around, so had to order these and wait a few days, unfortunately. Alright, here's what we're looking like. Nothing's adjusted. It's just sitting there. I will need to go ahead and adjust that exhaust so you can't see it through the hood stack, but it certainly looks like a hood. Now, it's obviously not perfect. There are certainly still plenty of spots where the sheet metal is a little crumbled and not looking right, or even the wrong shape entirely. But this is an off-road rig. It's gonna get beat up anyways. I'm not gonna spend all my time worrying about making it perfect. This is good enough for me. It's time to slap a little bit of Bondo on it and paint the thing. So this turned out okay, but not perfect. The problem is that there's lots of spots where I put on Bondo where I couldn't really see the issues as well before I put the primer on, but now I see the issues and there's some spots that need some fixing. There's also a couple runs up here that need fixed. I'm gonna take a risk here and I'm gonna try to sand out the bad areas. I'm getting flashbacks to when I did my fenders and it was sand, Bondo, prime, sand it off, Bondo, prime, sand it off, Bondo, prime. And I just did that repeatedly and it never even turned out that well. So I'm not gonna try and go overkill, but I am gonna try and blend some of these areas where the Bondo is kind of in the way. I think this will actually turn out pretty well if I can blend out some of these bad spots. Here's to hoping that I'm not about to fall down the rabbit hole and have to redo this 15 times because I decided to sand and then reprime it. Maybe I learned something from the fenders, maybe I didn't. Let's see. Other than the fact that the panel was bent to begin with, this actually turned out really well now that it's dried. There's a few paint runs in a few different spots, so I'm gonna sand those out, and then rather than mixing up an entire new batch of this paint, I'm just gonna hit it with some rattle can primer to touch up where I have to sand. And other than that, I think I'm about ready to throw the final color on this, which is exciting. There's a little bit of discoloration where the paint went over the Bondo. Wonder if scuffing the whole thing with 400 grit or something would help with that or not. We'll see. So the paint was starting to look pretty decent on this thing, but I screwed it up. I'm not entirely sure what my problem is. I have this Rust-Oleum primer and Rust-Oleum gloss white color. So I sprayed primer, waited till it was tacky, sprayed color, waited till it was tacky, sprayed color. And then I put the clear coat on. And when I put the clear coat on, I immediately started getting some wrinkles maybe after 10 minutes. And then I left it overnight, came back out, and it had washed the color coat off. So I'm not sure exactly what the problem is. The color says protective enamel, oil-based. So does the primer. The clear coat says ready to spray lacquer. Doesn't give me any other info other than that. I think what happened is I don't think the lacquer is compatible with the oil. Either that or I just needed to give this a full 24 hours to dry before I sprayed the clear coat. I don't know. I'm not a chemist and I'm not a painter. It looked really good when I just had color on it, so I'm just gonna leave it at the color. I'm not gonna try and clear coat it again. Let me know in the comments if you think the problem was that this is lacquer based and if there's something else I should have gone with on the clear coat, or if I just needed to let it dry a little longer. Not sure which one's which. For now, I'm gonna sand this down again, probably reshoot 1 layer of primer, reshoot 2 or 3 layers of color, and I'm gonna call it good. Some spots look half decent, like up here. I had tried to hit the back with a test coat every time before I did a coat on the front, and the back turned out just fine. But that would lead me to believe that probably there is a way to get this gloss to work. I just don't know if I wanna risk it. Well, that's how the hood turned out after the final layer of paint. And I think it turned out pretty well, actually. I showed it to my partner and she looked at it and she says, oh, it looks like a stock hood that's been in an accident. Now, I spent 3 months building this thing, so looks like it has been in an accident is not quite what I was shooting for. But the fact that it looks like it's a stock hood is actually pretty impressive. The irony is that this part where I did that stamping on my own, it turned out really well. The stamping the channels was what I thought was gonna be the most difficult part, and that turned out pretty good with my little shop press. The mistake I made is that this section that I added was thicker metal than the rest of the hood. I measured the hood, saw that the gauge was incredibly thin, and I thought, oh, that's gonna be crappy to weld. I better up it a gauge or two when I add this piece in the center. What I didn't think about when I did that was the fact that I was counting on the hood to get the shape of the insert right. What I relied on was tacking it onto the existing hood, bending, tacking, bending, tacking. And when this part was thicker than this part, all that served to do was bend up this part rather than getting me the nice smooth curve I needed. So I thought I was making my life easier getting the thicker, nicer sheet metal. I thought it would make welding easier. But in the end, all it did is bend up the hood. But it's going on an off-roader. I'm not gonna spend another 3 months just trying to make it look pretty. I'm going to put it on my car and I'm gonna drive it. In the future, if I were to ever do something like this again, I would either A, use a much thinner sheet metal here and actually find a way to roll it into shape before I welded it on rather than just relying on the existing hood to keep it into shape. Or B, I would just cut out this whole shape from a piece of sheet metal and use that. I originally thought of doing that, but I don't have sheet metal tools, so I had no way to get the curve this way, the curve this way, and I couldn't make these channels on my own. This whole hood would not fit in my press. I could only fit that much of the hood in my press. So short of having better sheet metal tools, this is what I thought would work. It works decent, but in the future, I'd probably do this different. This hood took so much longer than I expected it to. This hood has hundreds and hundreds of hours into it, and I was not expecting that when I first started. And although the final product didn't turn out perfect, what I did get from those hundreds of hours spent doing this is I really learned a lot. I learned a lot about sheet metal, I learned a lot about painting. Next time I have to do a project like this, it's gonna turn out a lot better than this one. So it wasn't time wasted, I'm glad I did it, and this is serviceable. Let's get this hood put back together. All right, here it is. It's working. I added a hood prop. You can't see the exhaust through the short little hood stack. It doesn't look perfect. There's some gaps here on the side and some gaps there in the back, but I've got some rubber I'm gonna try and use to fill those gaps and make it look a little better. Overall, this is a functional hood. Let's fill those final gaps. This fender gap here is just horrible. It's not nearly as bad on the other side. Part of the problem is that the fender actually comes in a 1/4 inch or more right here, and it doesn't have a firm edge on it like it ought to. This must have been the first fender I did because the other fender isn't nearly as bad. So it's a problem that started with the fender that I didn't notice was this bad until I got the hood on, and then it was compounded by the hood. I came up with a quick and dirty way I'm gonna at least cover this. I decided that what I would do was I would buy some white TPU for my 3D printer. That's an elastomer. It actually is a rubber, it's flexible. And I'm gonna use this as a gasket to fill this area. This area is 40 to 50 inches long, which obviously I can't print on my 3D printer in one go, so I had to print it in 3 passes, and this is what I ended up with. I'm gonna glue or plastic weld these together, and then once I have one long continuous piece, I'm gonna take some molding tape. It's double-sided tape that is designed to put molding and trimming on cars, so it's supposed to stick really good and work really well, and I'm going to stick the gasket down with that. Now this isn't gonna look perfect. It's gonna be kind of weird having a rubber lining in this panel gap on one side, but at the very least it's going to keep dirt and moisture out. It's going to give a slightly more uniform look to just having a giant gap there. It's janky, but it works. We'll see how this turns out and see if it ends up being acceptable or not. Wish me luck. This poor Explorer had no idea what was coming when I decided to do an engine swap on it. Hope it forgives me. As you can see, the passenger side, I mean, there's still a big gap here, but this is a lot more what I would have expected as a panel gap when I did this. For the passenger side, I'm gonna print another gasket like this, but I'm not gonna include this little wing shape. I'll remove that shape and just keep the rectangular cross section. And that should be adequate for this side because the gap's not as bad. The nice thing about 3D printed materials is that they're all thermopolymers, meaning you can melt them and then reform them into a different shape. Now this is obviously true for all FDM style printers because that's how they work. The filament has to be meltable and reformable. And this isn't true for all plastics and rubbers. Things like Teflon, Delrin, acetal, if you try and melt all of those, they'll just burn. It's a very simple process. It can be done with a tool that's basically like a soldering iron. You can even use some spare plastic filament like a welding rod and fill any holes if you need to. Like if your printer had some printing mistakes and missed some spots. Notice the little fire there. It's because plastic's combustible. You don't want to get it too hot. And now these pieces should be held together pretty firmly. And that's about all the time this one is going to give me for talking without whining, so back to puppy sitting, I guess. Alright, so I've got a functional hood now, even if it's not that pretty, and there's only one more major component that's needed to make this a complete car. I'll let you guess what it is. Now don't get me wrong, there's a lot more I want to do to it, but there's only one more thing that'll make it a complete car. Join me next time when I do that. Thanks for hanging out with me in my garage today. I hope to see you next time. Now, get out there and build something.